All right, so our warm-up for today, s equals 2 pi r squared plus 2 pi r h. Solve the equation for the given variable, justify each step. It wants us to solve for h. So what we have to do is we have to rewrite what's given. So it's s equals 2 pi r squared plus 2 pi h. And remember, that is what's given. So then our next step is we want to start solving for that h. So what I did was I subtracted 2 pi r squared from both sides. And that was the subtraction property of equality. And then from here, we got s minus 2 pi r squared equals 2 pi h. Divide by 2 pi, divide by 2 pi. We end up with s minus 2 pi r squared over 2 pi equals h. And this was the division property of equality. And then when we get to this point, now sometimes the book is going to reverse these, and they're going to say that they use the symmetric property of equality, which they did, because they want to write h equals, they're trying to write h equal to s minus 2 pi r squared over 2 pi, and that's fine. I don't do that all the time. The reason is because I feel like it's the same statement. You can if you want to, but if you didn't do that on a quiz or a test, I wouldn't take any points off, okay? But that is the symmetric property of equality, if you want it to look nice with h on the left side of the equation. All right, cool. Let's go ahead and talk about lesson 2.5. Guys, just a quick heads up, this is a very difficult lesson. So if you are, by the end of it, still unfamiliar with proofs, my recommendation is look up a lot of geometric proofs. Get familiar with them, start to see patterns in how they're solving proofs, because this is a very important lesson, even though it is very hard. So moving on, 2-column proofs. So a proof is a logical argument that shows a statement is true. Various formats include a flowchart, a paragraph. We're going to use this one, the 2-column format. So I want you guys to star that one. And that's where we have the statements on the left and the reasons on the right. We've already done some examples of this, but we're going to do them with geometric statements now. So given info or the result of applying a known corresponding property or fact. And then the reasons are the explanation for each statement. So a reason goes with each statement. So acceptable reasons in a proof. So given certain information, or given information could be used in a proof. That could be from a diagram. It could be from the actual problem. Definitions can be used, properties, postulates, theorems, and previously proven theorems. And we'll get to talking about that. What you can't use in a proof is because I think so. Yes, I have gotten that before. You cannot, not an acceptable reason. Okay? Don't use because I think so, because it looks like it is. Any of that stuff is not a good reason, okay? We need to be using our math skills in order to prove things in geometry. And then for theorems, underneath here, I want you to write down that geometry is cumulative. And what that means is that we're going to build off of each other. So if we learned a proof or a theorem in the past, you can use that proof or theorem going forward in future proofs. So just write proofs, build off each other. All right, next slide. So a theorem is a statement that can be proven, and it's proven using deductive reasoning. So theorem 2.1 is stating that properties of segment congruence. So segment congruence is reflexive, symmetric, and transitive. And then theorem 2.2 is properties of angle congruence. It's applying those three same properties to angles. And we're going to go over exactly what that means. So for the theorems that we just talked about, the reflexive property. So that's stating that line segment DE will be congruent with line segment DE. Simple enough. Also, angle D will be congruent with angle D. The symmetric property. So if DE line segment is congruent with FG, then the line segment FG is congruent with DE. You can just flip the congruence or flip the line segments over the congruent sign, okay? And then same thing for angles. So if angle A is congruent with angle B, then angle B is congruent with angle A. Pretty self-explanatory. The transitive property, it also gets applied to line segments and angles. So let's talk about that one. So for the transitive property, let's take AB. So if AB is congruent with CD and, and CD is congruent with EF, then AB is congruent with EF. And then for angles, if angle A is congruent with angle B, and angle B is congruent with angle C, then angle A must be congruent with angle C. So, example 1, write a 2-column proof. So, writing a 2-column proof. AC, what's given is that AC equals AB plus AB. So, in this line segment, this distance right here from A to B, if you were to double it, you would get the distance between A and C. And it's saying use this to prove that the line segment AB has the same length as the line segment BC. So in order to do that, it gives us the proof, okay? These are all the statements of the proof. And what we have to do is come up with the reasons why they're true. So this first one is the most obvious. That's just what was given because it told us this up here, okay? So this is given. The second one, so going from steps 1 to step 2, okay? AB plus BC equals AC. Well, we know that from the segment addition postulate because B lies between A and C, therefore we can state that. So this is the segment addition postulate. Step 3, so all they did here was they took, since this AC is AB plus BC, and this AC is AB plus AB, they set both of those equal to each other because AC does in fact equal AC by their reflexive property. So then they just set this portion equal to this portion, and that's called the substitution property. Property of equality. And then in step 4, all they did was they subtracted AB from both sides. to get AB equals BC, and that was the subtraction property of equality. Okay. Next slide, example 2. So write a 2-column proof. Same thing, it's giving us all the statements, and we have to come up with the reasons why that's true. So M is the midpoint of AB, and it wants us to prove that AB equals 2 times AM, and it wants us to prove that AM equals 1/2 AB. So it starts with M is the midpoint of AB. That is, number 1 is given. Number 2, it says that AM is congruent with MB. And that is from the definition of a midpoint. Okay, because if it indeed lies in the middle, then the distance between the two of them should be, the distance from A to M should be congruent with the distance from M to B. So now it says AM equals MB. That is just the definition of congruence. Number 4, AM plus MB equals AB. That is the segment addition postulate. Number 5, AM plus AM equals AB. That's because we substituted AM equals MB. So we plugged in AM for MB in this equation. So that was the substitution. Property of equality. Number 6. In order to get there, all we did was add like terms. So this would be considered a simplify step. And then to get from step 6 to step 7, we use the division. Property of equality. Okay, so writing a 2-column proof. Guys, this is just an example of another proof. So given that angle 1 is congruent with angle 2, it wants us to prove that angle 2 is then congruent with angle 1. So basically prove the symmetric property. And what they did here was they wrote that if angle 1 is congruent with angle 2, that's given. The definition of congruent angles states that their measures must be equal. So the measure of angle 1 equals the measure of angle 2. Using the symmetric property of equality, they can flip it, and then the definition of congruent angles, they can say that angle 2 is congruent to angle 1. Okay? So just using what we already knew in order to apply it, we already know that the congruence property for angles can be written as symmetric. I told you guys that in an earlier slide. So this is just showing how we can say that. And here's your homework. Good luck.